Thank you, Martin. So first of all, welcome from my side. Hardy and I am excited to share some valuable insights on how we are monitoring our very large network infrastructure. And as Matthias already said today, we are dealing with around about 100,000 hosts. At first, we'll introduce ourselves and our firms and have a quick look at who we are and what we do before we get into the requirements and challenges that come with such a large network monitoring. After that, I'll give a quick look about the architecture and how that interferes with our performance before Hardy goes into customer-specific solutions and introduces everything we've built so far, or quite a lot of that. After that, certainly a highlight of the presentation will be the layer 2 topology, who is automatically created, and we have quite a bit of film for that. And of course, in the end, we still have time for some questions. So let's start with you, Hardy.
Okay, hello together. My name is Hardy Duttmann. I'm one of the founders of the company Teratio. My colleague Rolf and I founded the company in 2001, so we exist already over 20 years now. Our core competence at this time was already network and system management. However, we are not coming from typical open source monitoring. We have grown up with monitoring systems like IBM Tivoli, HP OpenView, or BMC Petrol. I think it started in 2010 that many of our customers were asking for more affordable monitoring systems. And so we analyzed the market, but quickly agreed that core Nagios is not a solution for us. It was too administration intensive in our eyes and also not suitable for large customers. This changed when Checkmk crossed our way, and we finished our first Checkmk project in 2012 with the free open monitoring distribution 0.4. And from that time, we have realized a lot of Checkmk projects. We are Checkmk partner since 2014. Actually, we're Checkmk Gold partner and serving more than 100 customers directly with subscriptions, projects, support, and development.
Yes, I'm Leon Stock. I'm working at the Finanz Informatik, and the Finanz Informatik and we are the IT service provider for the saving banks finance group here in Germany. We've got over 4,400 employees located in Frankfurt, Hanover, and Münster, and therefore we are responsible for around about 112 million bank accounts, which result in around about 153 billion technical transactions per year. And those are realized by our 4G redundant data centers, who should give us maximum reliability for every technical transactions and, of course, for our customers as well. But, of course, we also specialize in various other directions, such as training, support, and consulting. So, all in all, you can say we deliver the full IT service package for the Saving Banks Finance Group, including a fully private network and the monitoring of that. When I'm talking about our customers, I'm talking about mostly saving banks, of course, because it's the Saving Banks Finance Group. We've got 376 saving banks, but also insurances, direct banks, building societies, and a few other customers where you might think we've got a lot of different requirements that come to us, and you're right with that. One of the biggest requirements is, as I said, the fully private network. And the fully private network consists of a few numbers here, around about 60,000 WAN and LAN hosts, also a few access points, of course, other hosts such as logical and dummy hosts, and interestingly enough, our 3,200 central hosts who we are responsible for, and those hosts are the hosts we need for ourselves, and I'll come back to those later. Also, we've got 50 to 100 concurrent users, depends on the day, of course. But I'll come to that. And the requirements and challenges again, as I said, we've got 100,000 hosts, or quite a bit above that. It's 108,000 right now, as you can see on the right side. And also this environment with over 3.5 million services changes rapidly. So we have daily changes in the infrastructure and have to deal with around about 500 host changes per night. Our 50 concurrent users, who obviously click in the GUI then, are strongly increasing, so we plan to have around about 300 users at the end of this year, which also is quite a requirement of, or rather a challenge for the performance in the system. With our automatic provision, we also create a lot of network discovery rules, such as 13,000 and a bit. Also 30 custom attributes, 400 different tag values, and 44,000 different labels, which results in a configuration size on our main site from over 700 megabytes. So just you have a few numbers. All right, let's get into the architecture. Here you can see how we build our system. Our system is based on 12 monitoring sites, based on the Checkmk appliance cluster Rec 4 Plus, but we also boosted them quite a bit. So now we've got 48 CPUs, 128 gig RAM, and 4 terabyte SSDs over those clusters. And those clusters are distributed over 2 of our 4 data centers. So we kind of divided Germany into several parts, and the clusters who are relevant for the northern part of Germany are in Hanover and Pattensen, as you can see on the bottom left, and the clusters for the southern part of Germany, Münster and Greven, you see on the bottom right. And all our sites are connected to the main and view side, of course. But let's talk about the clusters first. Our largest site contains around about 18,500 hosts, whereas, funnily enough, this isn't our biggest site in terms of services. Here come the central site services into play, where we've got quite a bit over 3,000 hosts, but also 700,000 services on them. So you can say we've got like less than 3% of our hosts make up for over 20% of our total services. This also comes with quite a challenge regarding to performance, so therefore we are planning to split that side up in the future, but it is as it is now. Right, the main site is where you can configure and use other user operations on. You can use every interface on there, wherefore as on the view side, we build those for user performance. You can only access quite a few features and have reading rights only. So much about our architecture and our requirements in terms of performance. Hardy, how did we deal with those?
Well, I think it's clear then we talk about 100,000 hosts, we have to talk about Checkmk performance, especially when we're talking about 99% SNMP objects which are pulled from the monitoring systems. And I think many of you know this, that there are still network devices out there which don't like SNMP, especially when it comes to SNMP version 3. So the first thing we have done at the beginning of the project, we have changed the default check-interval from 1 minute to 5 minutes for the whole environment. This also reduces the load on the network components, because Checkmk is often not the only tool which is pulling the components. There are a lot of other tools which make SNMP balls against the monitored devices. And then we know everybody, Checkmk comes with a lot of checks, also for SNMP components and for the specific SNMP devices. And there are much more checks in the community out there. But if you run Checkmk in debug mode, you can see that there are SNMP OIDs which really respond very slow to the request, and other OIDs which respond very fast. So the first thing we also met is that we disabled the checks we do not need. One special check which is really slow and which increases the polling time a lot was the quality of Cisco check, quality of service check against Cisco devices, which we disabled directly. And then we have to talk about the Checkmk fetcher, and that's a really good news. You can increase the Checkmk fetcher to a really large value. I think we have about 350 Checkmk fetchers on our largest site. But the only thing you have to watch, especially when you're still on version 2.0, that within core restarts, when you have installed new extension packages or make other changes which requires a core restart, that it can be that the core stops and is not started again during the activation process. I think this problem does not exist in 2.1 anymore. We don't have this problem any longer, but in 2.0 we have this problem. Well, we do not just have 100,000 hosts, we also have a lot of tags, we have a lot of custom attributes, and a lot of labels. And
GCP
we have
health.
an overall site config on the main site of 700 megabytes. When we started with the project, it was an early version of, early beta version of 2.0, and we have provisioned the first 50,000 devices and activated the changes. It takes 4 minutes. So, okay, we see, okay, it was an early version, beta version of 2.0, but it was clear that we have to do something. And what we have implemented, we implemented a Vato hook, which reduces the site config on the remote sites to only the configuration the remote sites needs. During the activation process, the whole configuration is pushed to all sites, and before the activation, all folders are deleted, which are not needed on the remote sites. Within the Finanz Informatik, this was very simple because the site assignment was done at the top folder level of Vato. And then we also made some really interesting debug session with Andreas Bösel from the development team, and he optimized the activation changes process. And so we are now under 110 seconds again when activating the changes of remote sites. Okay, another point is that when we're talking about network monitoring, it's clear that network monitoring needs pings, and we just don't need pings, we also need ping performance graphs. So we decided to use the smart ping for the host states, to continue to use the smart ping for the host states, but the smart ping does not create any performance graphs, and create an additional ping service for the performance graphs. But this additional ping service uses the active check helpers, so we have to increase the active check helpers. This was not the problem, yeah? But on the other side, we're make intensive usage of the Checkmk hardened software inventory. And the Checkmk hardened software inventory uses a lot of memory. Each Checkmk hardened software inventory processes reads at the beginning the whole configuration from Checkmk and then polls the device. And therefore, we had to increase the memory from the Rec 4 Plus appliance from 64 gigabytes to 128 gigabytes. I think this is the default now when you order this appliance, but at that time we just had 64 and this was not enough. And this was problematic when the inventory starts for a lot of devices. So we had to find the right balance between the number of active check helpers for the ping services and other active checks and the hardened software inventory. We also need to talk about administrative performance. Yeah? I think it's clear that you cannot create 100,000 hosts in Checkmk manually, yeah? Even if you have 500 changes per day. So when we started with the project, we built an interface to the FNT command configuration database, where the whole network is planned and documented within the Finanz Informatik. And actually, there's a nightly job running which creates all the hosts or deletes hosts which are decommissioned, or edits all the tags, labels, and attributes if there are changes to the hosts. In phase 2 of the project, which will be accomplished in the next 2 weeks, we have changed the API to the new REST API of Checkmk, and then it's also possible to trigger a provisioning run for just a simple location of a saving bank. Yeah? So when the technical field service out there adds a new or installed a new switch or made changes to existing switches, the operational teams can trigger this provisioning for this location, and everything is created, and the service discovery runs, and he can check if the location is okay. But we are not only creating hosts during the discovery runs, we also create a lot of interface discovery rules. The main reason for this is that we have frequent bandwidth changes on the WAN connections, and the physical bandwidth of the interfaces does not match the logical bandwidth of the WAN. And if you want to make percentual WAN bandwidth usage monitoring, you need the logical bandwidth on the interfaces. We're doing this during the service discovery based on the network interface and switchboard rules, and we're creating 13,000 network interface and switchboard discovery rules within Checkmk, and we are not creating the rules, and during the discovery of the devices, the interfaces are labeled with the correct bandwidth, and then there are other rules which monitor the bandwidth. We also have to check if the current label is has still the same bandwidth as the configuration in FNT command, because actually Checkmk does not recognize when a discovered service label changes. So we have to do this within our interface. We check if the actual bandwidth of the WAN connection is the same as the labeled service. And if it's not, we make a rediscovery. hopefully this will be changed in the future, that Checkmk recognizes when discovered service label changes. Yeah, here you can see some screenshots. We had about 13,000 network interface and switchboard discovery rules and a lot of service label rules out there. Okay, in such a large environment, even if you automate everything, sometimes it's necessary to make a manual discovery of a network component. And the manual rediscovery of a network component takes really long. I think most of you know the process. You go on a device, click the Edit Service button, and if you have a really large environment, Checkmk loads all the rules, and it just takes too long for the operational teams. And if you want to discover multiple devices, which you have actually in a view, the way to the setup part of Checkmk and to make a background discovery for the multiple devices is also a long way. So we have integrated some commands. One of the commands is a background discovery command, which can be executed in the front end, and then the background discovery is executed within the next 10 minutes. So you don't have to go to the setup. You can directly initiate it from the normal views or dashboards. As I mentioned before, we have a 5-minute poll interval, but sometimes it's necessary to make a deeper analysis with a faster poll interval. And you cannot just change the check interval of one Checkmk system to 30 seconds or 1 minute, because around robin databases must also be changed, and this is really too complicated. Therefore, we have implemented the fastball host creation job, which creates a host in the background with the ending fastball, and this host just polls interfaces and monitors the interfaces for a limited time in a 30-second or 1-minute poll interval, and it just monitors interfaces. And the interface graphs are linked to the original host. I have a short screencast later for this. Yeah. And we have to talk about the operational performance. We have a lot of users concurrent users clicking in the GUI, and we have the update to Checkmk 2.1 was a really performance boost for us. Yeah, it was more smooth and everything works more faster, and it's a really good idea if you have performance problems with clicking in the GUI to update to 2.1 if you have not already done it. Another thing is, if you are using filters and you're using specific filters, the data, and we have a lot of data in there, is already filtered in the live status queries and not filtered in the GUI. And this is also really good. You can enable the live status debug mode, and then you can see if the data is filtered within the live status request or if it's filtered in the GUI. Okay, here is a short screencast, and you can see how the fastball host command worked. We implemented a few more commands. There is a background discovery command. You can initiate it on one device or multiple devices via normal command selection. Yeah, you can say, okay, for these devices I want to make a background discovery and everything is scheduled within the next 10 minutes. Or I want to create a fastball host, and this host is linked directly to the original host, and the interfaces are polled for a limited time for deeper diagnostics in a 30-second or 1-minute interval. When you now click the original host, there is a new icon on the interfaces. Yeah, I think we also have a lot of combined checks. You see the green icon, the yellow icon is the normal icon, and the green icon links you direct to the fastball information with a 30-second interval on the fastball host, so that you have a deeper analysis here. And when the time which was added at the beginning is over, the fastball host is created automatically and the data is deleted. Yeah. So that's a very easy way to create hosts with a faster poll interval for a specific time.
All right, so much so to our requirements and challenges regarding the performance. Let's come to some monitoring requirements where we kind of split it up into two phases because we kind of had two projects. The first project was replacing the CA Performance Manager, where the CA Performance Manager hosted different types of reports to a lot of teams. mostly with bandwidth monitoring for the WAN colleagues, but also for the sales team. We had different compliance monitorings in the CA Performance Manager, and also lots of special other monitoring checks. And so we kind of needed to implement all of those into Checkmk. Didn't really have that much of a problem. Of course, there's always some, but when phase 2 started with the replacement of the CA Spectrum, there was a huge point. First, of course, the Spectrum is the typical availability monitoring. In our context, the Spectrum had a lot of interfaces. I'm talking a lot of interfaces to various tools in our network management. And so we kind of had to migrate them to our landscape and even to Checkmk. What a huge problem, or a challenge rather, was the layer 2 visualization of the central network of our customers and of locations of our customers. Since you might think if one of our customers has like 4,000 network components, why would I want to see a layer 2 visualization of 4,000 components? It doesn't really help in troubleshooting. So these were the biggest points in the monitoring requirements. The user requirements we kind of split those up into 4 parts, or rather 4 teams. We've got the WAN, the LAN, the operating and the sales team, where WAN and LAN mostly just need in-depth analysis and monitoring of either provided traffic for the WAN colleagues and their product, the OSPN, or they need in-depth analysis of network access and stuff from WAN and WLAN, of course. The operating team also needs in-depth analysis, talking about like first-level support, but they do not need that deep of a level. And of course, the sales just needs top-level status and bandwidth information, just really top-level information for customer advisory. And therefore, we've got 4 different teams with hugely different requirements for dashboarding and so on.
Well, as Leon mentioned, the first part of the project was a replacement of the CA Performance Manager. And the main monitoring functions of the CA Performance Manager was monitoring the bandwidth, some errors, and creating a lot of reports. And one of the main reports which should be migrated to Checkmk was the customer WAN bandwidth report, which is sent to all the saving banks on a weekly or monthly basis for 400 customers in 14,000 locations. And the reports had a specific order in the locations. So what we have done is we have created a simple web interface within the Checkmk rules engine to maintain the recipient email addresses. And then before each report generation, all reports are totally recreated within Checkmk based on the FNT command database. And this is file-based. The creation of the report is based on file because there's actually no API for this. Then the reports are externally generated via a web call and saved in the file system, and then the reports are sent to the customers, to the saving banks. Then the CA Performance Manager also created a lot of CSV files, and we also migrated this externally to Checkmk with some interface scripts which collects the data from Checkmk, creates a lot of CSV files each night. We're talking about 30,000 network objects, and also there we have frequent bandwidth changes, and so we use the data from FNT command. And last, we had a lot of static reports which are totally created in Checkmk manually or partly manually, and which also uses the Checkmk scheduler. These are, for example, the internal firewall capacity management reports or the customer VLAN reports. Yeah, another requirement Leon mentioned from the 4 teams. We have 5 teams here. With the sales teams is mainly working with the PDFs which are created, but we have 4 teams which need fast access to the locations or to the saving banks. Yeah, so, and we have 400 customers, 4 different teams which needs fast access to a dashboard for the customer or to a dashboard for one of the 40,000 locations. And we have daily changes in the dashboard because every night we have 500 changes within the environment. And so we are talking about 60,000 dashboards, yeah, or just 12 dashboards with dynamic filters. And up to Checkmk 2.1, the filtering of dashboard was not so really flexible. So of course, manual creation of the dashboard is not an option. I think this is clear. Yeah? And then the dynamic linking from views, I think Lars told something today about this, was also not possible at that time. And we have to see if this is suitable for us in the future. So we have the virtual host tree. I think a lot of you know the virtual host tree. It's a sidebar snap-in where you can create filters based on tags, and you can say which dashboard is opened on which layer. But this was also not flexible enough. So we created 4 custom host trees. The code is mainly based on the virtual host tree with configurable dashboard and the use of context filters. And this is how it looks like. We have here the 4 custom host trees, and when you click on one of the host trees, when you click on a saving bank or on a location of the saving bank, then all filters for the dashboards are pre-filled. Yeah? And another possibility is to search for a bank in the search part of Checkmk. We extended the search plugin so you can search for an institute or a location. And then one of the dashboards for the specific team is opened, yeah, based on these filters. When it comes to the replacement of the CA spectrum, we had also a lot of requirements, and I will not show everything. I think we have more than customer-specific, really customer-specific extension packages developed. We have extended Cisco VLC checks and so on. One thing I want to show is a whitelist change, which is also a GUI implementation via the Checkmk command. It was part of the CA spectrum, and it was really intensively used from the operational teams. A whitelist change is a change which is not critical on one network device or on multiple network devices, so that the users can log on to the device. And this must be documented in the change management system. And this looks like the following. We have here some devices, and if you want to create a whitelist change for one or multiple devices, you just select the checkboxes once again, and then you mark the devices where you want to create the change for. Oh, this is the normal Checkmk command function, but when you generate the whitelist change and confirm it, then a new browser window is opened with all information pre-filled of these devices. Normally all the classes are filled. This is just a test environment, and you just have to enter the starting and ending date, and then in the change management system everything is filled, and that's it.
Right. So the last biggest requirement of the replacement of the CA spectrum was the layer 2 topology. And we started to divide that into more requirements itself, so we kind of had a better look at what is needed and how do teams even use it. The first requirement was definitely we need an automated creation of the topology. As Hardy already mentioned, we've got a lot of dashboards. We also would have gotten a lot of layer 2 topologies where we break it down to single institutes or even saving banks themselves or even our central hosts. So we definitely need automatic creation because manual maintenance just isn't an option. And as you might know, in Spectrum, this is the case. It gives really nice visualization, but then again, you need to manually maintain them. Therefore, Naquis also was never an option, and we had to come up with something different. Also, as Hardy already mentioned, our teams need really fast access to the layer 2 topology and their dashboards. Just for example, some of our customers call and they have difficulties with something. They need to be there within 1 or 2 clicks, and therefore Hardy will show how we implemented that. Also, since we have quite a lot of topology changes per night, we definitely need to see what changed in the topology, rather in the last 2 days, 4 days, 7 days, or even the last few hours. CDP and LDP lifetime is very short, so we kind of need to see what changed in the last couple of hours or days. Our fourth requirement was users need to be able to save changes. When we have such an amount of different layer 2 topologies, just filtered for the saving bank or institute, we need our teams to save their layout. So, such as the LAN team need to see where are the LAN hosts. They need to order them themselves, And therefore, the fourth requirement was we need persistent change out to the layout by the user himself. I think what's clear is that if you look at an institute of 300 or 400 or even 4,000 hosts, you need to see where the problems are and not where the good things are, right? So if a customer calls you and is having trouble, you need to troubleshoot and need really quick, visible information on what is wrong, even on the interface basis. The last requirement was rather a challenge for us because the topology data has to be created by the teams themselves. So the topology is only as good as the database, of course, as with every kind of automation. And therefore, the reliability in the topology data lies within the teams.
Okay, when we started with the layer 2 topology, I think I called the tribe or the Checkmk company and talked to the development guys and the product management. And they said, okay, this is a really difficult topic. Yeah? First of all, who is responsible for the data, which is really important? Who will build the topology data? And I think this was very fast clear that only the customer himself can be responsible for the data. It's not part of Checkmk to collect all the topology data. You can use function of Checkmk, of course, to collect the data, but building the topology JSON data file cannot be part of Checkmk. Everything else is in place. We have the JavaScript engine, which is already used within the parent-child topology or within the business intelligence, and it's a really good product which can also be used for other kind of topologies. So we made a small proof of concept. It was before the last conference, I think, and I met Andreas at the last conference, Andreas Bösel, and showed him what we have developed, and he said, hey, we have nearly the same. I've done the same thing also for another customer in a POC, but this was based on Netstart data. And this was the beginning of the layer 2 topology in Checkmk. Within the Finanz Informatik, we have 3 data sources, actually. The first one is we're collecting CDP data via the hard and software inventory, and we have more than 70% Cisco devices, and the CDP data delivers definitely the best data quality for device and interface matching. But we also have other devices, and therefore we are collecting LLDP data. The problem with LLDP data is that each manufacturer uses slightly different OIDs. Within some OIDs you have full qualified domain names, within other OIDs you have lower cases host names, or the interface alias is part of the OID. So we had to write a lot of hard and software inventory checks for different device types to get the data from the LLDP data. And the third part of the topology database is the FNT command data, once again. The providers do not allow us to get the LLDP or CDP data from their devices. They allow us SMNP access, but we do not get any information of neighborhoods within the network monitoring. And therefore, we mixed up the FNT command configuration data with all the other topology information we get to make a full topology of the layer 2 network within the Finanz Informatik. The data is daily generated, and we have a monthly data retention interval. And at the end, the topology information is just one file. It's a topology JSON file with history. And this is how it looks like. We have here a small test environment with a small institute, and on the right side you can see our host trees, and our host trees are also the first way to the Checkmk topology. There is a small icon, here you can see the dashboard, there's a small icon for one location, and the first time when you open the topology, you can see all the devices within this location, it's a smaller location, and the connection between these locations. And if you want some more information, you can just toggle the interfaces, and then you can see the connection from one switch over which interface it is connected to the other switches, and we get information for the host state, and we also get flyover effects with performeters and performance graphs and problematical services. And this is really good information, especially for the operational teams. They get a call and say, hey, here's something wrong with our location, and they will check this way. But there was also the requirement that you can define your own layout for the topology, for the locations, or for the whole customer. Yeah? And here we have a location which has a high availability connection via 2 providers. And so we are starting at the left side. There is the CPE device from the provider. Then comes the high availability switches. The next part are the VPN gateways, which you can place on the map. And then comes the major switches of the location. And then we have some smaller switches. And of course, you can also change the layout. You can not just use the star layout. You can also create another layout, or you can rotate it. I will show this in the slides now. You can grow up it. I think these are all functions which also can be used in the parent-child topology, or some of them. Yeah? And of course, you can also just toggle interfaces for specific devices, so that the operational team can create their layout for the layer 2 topology of customers or locations. And yeah, I toggle the interfaces now for devices. And then when you're finished with the first time you have accessed this location, it's of course very important that you save this layout, so the next time when you come to it, that you have directly the layout you want. Yeah? So when we come back to the device, you see the layout is there. It's opened with this layout, and each team can define its own layout, and it looks like the Enterprise One, I think, here in this part. Yeah. Then, another function which was requested was that we have to see changes in the topology. Here we have a missing, I'm not sure if everybody of you can see it, there is a line missing between one switch and another switch. So there is a missing information in the topology. And what you can do, you can compare the current day against the last 30 days. So you can compare it against yesterday or the day before yesterday. And then there are lines marked in another color. So you see this line is missing in reference, and there must be some changes to the devices. So you can, you can now see which changes has happened in the last days. The last requirement was regarding problematic interfaces or problem with interfaces. They should be directly visible in the topology, and we have an example for this here. You see that there is a NOV VPN gateway, and the interface for the VPN gateway is red. It's down perhaps, and therefore the connection to the switch is missing. And this also helps the operational teams when they get calls or tickets for this topology. Here you see the whole topology for this small customer. You see the critical devices, you see the interfaces, and the information. Yeah, and that's the new layer 2 topology. You are absolutely, the data must be created by your own. And the good news is, that this topology will be available in Checkmk 2.2 as extension package, I think, within the next weeks, and it's part of Checkmk 2.3. Okay, thank you very much.
Test. Can you hear me? Yeah. Leon and Hardy, how often do you activate changes?
Manually or automatically?
How often do you do it manually?
Hopefully not so often, yeah. So normally all the things are discovered automatically, and as we use the background discovery, we are just activating changes when we are changing manual created rules, yeah. And this is not so often, I think.
Yep. Yeah. And how often do you do it automatically?
I think every 15 minutes.
Okay. There's a question there.
Ich kann, glaube ich, laut genug reden, ja, fein. Wie lange hat es denn gedauert, bis das fertig war? Wie lange hat es denn gedauert, bis das fertig war? Also sprich vor allem das Topology zusammenstellen, die ganzen Daten, die Korrektur von den SNMP-Variablen und so. Wenn du das auf eine Zeitlinie packen willst, mach mal Tage, Monate, Wochen, Jahre.
I will just translate to English.
Oh, sorry,
okay.
sorry. I had to
no
speak.
worries. You can,
Sorry,
I think,
no, it's fine.
I forgot it.
Do you want to
I
translate
understand it.
yourself?
Yeah, I think. Okay, how long does it take to create all the data? This was really one of the main parts. You're absolutely right. And I think we started with the first test before the last conference. We started with the CDP data. This was really easy because Cisco devices, no problem. They're using the host names. You have no problems.
But the middle part.
The middle part.
Part 2.
Yeah, then we come to LLDP. So we had HP devices, and then you recognize, okay, one HP device does deliver other data or other OIDs, or the content is different. And this really takes a long time. We have created a lot of extension packages for specific devices. And well, I think we are now learning that there are still devices which have slightly different OIDs, and then we have to extend it. This is really a problem.
Okay, one more question, if I'm allowed to. So the part of working together with the LAN/WAN team, how did you do this? Are they completely, let's say, flashed with your approach, and then they deliver all the information? So how was the thing going on?
No, that was quite the opposite direction actually, because the CI Spectrum had a very nice visualization of those maps, and when we wanted to migrate from Spectrum to Checkmk, they already had their intent set to get a good map, and so when we want to automate the map so you have less work, delivers good data, and they agreed to that.
Okay, thanks a lot.
Okay, the fast poll feature, is that an official Checkmk feature?
No, it's just a special implementation for the customer. Yeah? It's because I think it's also really customer specific. Yeah? We have a normal check interval for 5 minutes, and we have hosts in Checkmk with many labels and many tags. And if you create a fastball host, you also have to overtake these tags and labels. And this is really customer specific. I think when you understand the technique behind this, it's very easy to create. You just have to add a command, and then you have to create a script which adds the host to Checkmk, and from time to time it polls if it should be deleted. So it's not so complicated, but it's always customer specific, I think.
Okay, Leon, who manages the events from such a huge infrastructure, or all the notifications? How do you do that?
We got a lot of people who do. That's basically the answer. We've got a lot of different teams who also are specialized in various directions. So we've got obviously more than 4 teams who manage those over 100K hosts. But that's it.
Okay. Then thank you very much. Thank you for helping us bringing this network topology also to Checkmk, the visualization. And
okay. Thank you.
Thank you.
Thanks.
Bye.